Hi, Roland Yap from National Institute. Why can't you reduce the overhead down to almost zero? Is it because of cache issues?
No, so actually, consider we have all the stack objects that need to be protected. Let's take the stack canary as an example. So there is a strong stack canary which places the canary after all the buffers. So after the data guard analysis, we will be able to identify majority of the buffers are safe. So we will not need to place the checks after all the safe buffers. So in that case, we only have like a less amount of checks is needed and deployed, so we should be able to have lower runtime performance.
Okay, so what are the checks on the unsafe?
What's that?
What are the checks on the unsafe side?
So
safe, you don't need checks, right?
Yeah, unsafe objects do need checks, and all the safe objects are isolated on another isolated safe stack.
Correct, but what checks?
So currently in this paper, we utilize we only use the safe stack's runtime enforcement. We don't apply any other additional runtime defenses on the unsafe objects, but that is either theoretically or feasible. So we didn't test that in the paper, but it is feasible. We actually have the future work and our upcoming works. There's a paper in our group which will be on the OSDI 2022, which apply the data guard analysis on the kernel driver isolation approach. In that work, we have the shared data identification, we have the unsafe shared data and safe shared data, and we only protect the unsafe shared data in that framework using the isolation approach.
Okay, we'll continue offline.
Thank you.
Hi, Zephyr Yao from UC Irvine. Very impressive work, and congrats on this is a big project.
Thank you.
So my first question is, I probably missed the concolic execution part. What's the value you concretize? And my second question is, just want to brainstorm, is it possible to bring this static analysis into dynamic defense, like a stack canary with the value flow graph? Like, just wondering, is it possible to make this dynamic?
Yeah. So for the first question, for obtaining the soundness, we only concretize the constraint value, for example, the size. And all the other values in the symbolic execution remain symbolic. So in that case, we will be able to obtain all the possible execution paths. But that could easily run into the path explosion problem. So we have the state merging, we have the context sensitivity level, but we still set the timeout of the symbolic execution. And when the symbolic execution timeout, we see the object is unsafe. And for the second one, definitely it could be applicable to the runtime defenses. For example, we also explore using the safe code approach, which also utilize some sort of the runtime enforcement technique. And by utilizing the data guard in the first step, we will be able to not apply all the runtime defenses on all the objects, but we selectively apply the runtime defenses on the safe object, on the unsafe object.